Welcome everyone, I'm Josh and this is JSURIS. And today I'm going to be showing you some test equipment and radio equipment that I've recently acquired, as well as some items that I've had for a while already. Now, most of my videos up until now have been about metalworking, and while that is still probably going to be the primary focus of this channel, I will be doing quite a few electronics projects too, and they may become more prominent over time. Electronics is actually the main thing that is the basis of my career, so I have a lot of experience with electronics and test equipment in particular. Now, just last week, I got an oscilloscope, the first one that I've owned personally. So I'll be showing you that and some other items today. Now, this is sort of a mid-range oscilloscope, a mid to low-range oscilloscope that you might typically see. Many oscilloscopes made by Textronic or Fluke are in the thousands of dollars. This one is made by Rigol. Not as well known a company, but still they do produce quality test equipment, and this is at the lower end of their range. It cost about $400 with taxes included. And it's an oscilloscope that has about 200 megahertz of span, meaning it can measure signals from DC all the way up to 200 megahertz. It has two channels along with an external trigger channel there. And given that it's a digital oscilloscope, it has a lot of functions that really depend on what mode it's in, as well as the more traditional knobs for adjusting the horizontal and vertical aspects of it. So you've got your volts per division, and then you've got your time there. There's also your trigger level here. Now let's fire it up. Now it does take a little bit of time for it to boot up because, as you can see, it's basically a small computer with some additional equipment on it. There you go. Now it's currently set to its last state. If we click the auto set, it will just determine what settings it wants to use. Now you can see that you've got your flat line there. And what we're going to do now is show you what the test output looks like. Now this is going to be a square wave there. So what we're going to do is we're going to take a test lead. We're going to plug it in right here. It's got a quick release there. Then we're going to plug the ground onto the ground portion of the test. And then this portion is going to clip onto here. You can see it's like that. Now we don't necessarily have to, because as you can see it's well in there, but we can test. We can click the auto range, and that will set it to what it thinks the ideal range is. So if you look really closely, now you can see that this is a square wave, and we can measure based on the divisions how high it is. There's also other information given along there, and there's various functions. You can trigger on the front, you can trigger on the rear. Currently we're triggering on the front there. There's also a second channel we can hook up, and so you can put multiple things onto a single channel. However, if you look, I can change the time division with that one, and I can also change the volts per division. And that can let you view the stuff on your oscilloscope properly. The auto is pretty good, but with some signals it can be so-so. So you will sometimes have to manually adjust in order to get the kind of thing that you want. So that's that. We're going to be using this along with other test equipment to show you a variety of things with circuits and how these can be used. And yeah, let's move on to the next item. So as you can see here, I've got our next item, which is actually a radio. Now just as you can see, this is a Kenwood, and it's a TM281A. That will mean nothing to most of you, but it's a 2-meter band FM radio. It works at 144 megahertz, and it outputs 75 watts, so it's quite powerful. Now if you'll take a look, you can see it's got a very simple display. This is one that's designed to be mounted in a vehicle. As you can see, it's got mounting points there. The reason why I typically go with vehicle-mounted radios for VHF is because they typically have a lot more power output. And in fact, you can kind of tell at a glance that this thing has quite a bit of power output because pretty much the entire body is heatsink. It's quite impressive, actually. Now, while we're back here, we'll take a look. You've got your RF output here, to which you'll fix your antenna. You've also got a speaker output here. Now, that's going to be pretty useful. And, of course, your power, where you've got fuses. There's also an extension cable. Now, this is what you will actually plug into, and those go in like that, like that. And as you can see, you've just got these 2 leads at the end here. You can hook them up to whatever you want. And finally, we've got this. You can control most functions of the radio on here. And if you will observe, it plugs in via this right up front here. Right like that. Now I don't have it turned on right now, but I will show you it turned on. If you will give me a moment. I'm going to use this guy. Is this ideal? Not really, but it works. As you can see, she turns right on there, and we've got our display there. Now, the reason I'm showing you this is because we will be using the test equipment that I've shown you before to test this out, show you the output of it, and various other things with regard to it. Now this is an SDR. It's an SDR play. You might not be able to read that. It is an RSP2. Now this is a wideband radio. You can see it's got several inputs. VHF, UHF, microwave there, HF over there. They work very well. It's very good for monitoring a variety of signals. This is just for plugging you into a computer. I really like these because you can use them either as a receiver or as a spectrum analyzer. And even though spectrum analyzers are much better, this is good in a pinch, and there's all kinds of open source software available for it. So we'll be using this to measure the output of our radios and a variety of other things. It's very useful. It only costs a few $100s. This is a multimeter, as you can see. You can measure various different things. Resistance, diode check, continuity, HFE, which uses that to measure transistors. And then you can also go into current mode, which involves taking this guy and plugging it in either there or there. Now, as you can see, this guy is very useful. Use it for a lot of different things. Use it for fault finding, use it for measuring voltage, and I can actually show you to measure some AC voltage right now with this device. If you recall, this has a 5 volt on it. So we can take our one lead there and our one lead there, and as you can see, I can measure an AC voltage on it. I can also measure DC voltages too. Some of them are able to measure capacitance, some can measure inductance, but most of them are pretty simple, pretty straightforward. This is a very useful tool, so 2 thumbs up. Also, you'll notice this is not a super expensive one. You don't need a fluke or anything like that. You don't need to spend $1,000 on a multimeter. For home gamer stuff, you can use a low-priced one. Here we have a breadboard. Some of you may recognize this. It has multiple boards and some power and along each edge as well. And basically, this lets you put components along the center here, and then you've got your conductors that go off to the side. So I can put a component there, and I can interconnect it to something else or to something there. So we're going to be putting, I believe, 3 different circuits, or how many circuits? Yes, 3 different circuits. So we're going to have probably our square wave generator there, and then we're probably going to have our amplifier over there, and then our latch circuit over there. And these are really good for prototyping. Not so good for RF, but very good for prototyping. You can put things on it, and then it works. So, I hope that this video has helped you become more aware of some of the test equipment that I have, as well as some of the uses that it can be put to. You'll be seeing a lot more of this test equipment in the future, as I do a lot of projects, including the projects that I indicated when talking about the breadboard. Now, these projects will probably have their first videos posted about them in a week or 2. I realize it's been a while since my last video. Some stuff happens in life and you get delayed, but you should see some more content from me soon, so look forward to that. In the meantime, like, subscribe, and hit the notification bell to see whatever I post next.